Hi everybody, welcome to another one of our Camco videos. If you're looking to discover all new features and possibilities of our latest Integr8tor release, you have definitely come to the right place. My name is Dirk Leroy, I am with Camco in Belgium, and in this video I would like to take you on a tour around our v2023.12 Integr8tor release. Now, to do so, as you can see, I have this document, and in this case it's a web page which will be available to you as well shortly, if not yet the case. You will receive an email announcing the arrival of the new Integr8tor release, and with this email you will find a link that will take you to this page, or alternatively, if you browse to or you go to our Camco web page and you browse to our software page Integr8tor, there too you will find a reference to the same document, so that if after seeing and hearing this video there is still a number of items that you would like to review at your own time and convenience, then that is something that you can pick up from there. Okay. To guide me through this presentation, there's actually three big blocks that you see here. There is a part about QED extensions. There is an item on Gerber8 input, and there is a third one on performance and speed. Now, QED extensions, that usually means that we have added a number of analysis results data in our QED report, be it PDF or XML. So there is a number of items that I would like to expand on there. In the Gerber8 input, which is basically not new for this release, mind you, but there I would like to show you a little bit more about the enhanced possibilities of this Integr8tor release for inputting Gerber8 component data. And then finally, in number 3, the performance and speed improvements is an item where I will highlight a number of the items that we have achieved since our last release, and which will hopefully get you higher throughputs with the same accuracy as you have been used to from us all these years. So as you can see, a lot to do, little time to do it, so let's get started. Our QED extensions. Number 1 in the list is the differentiation between top and bottom solder mask and legend colors. And to do so, what I will do is I'm going to grab a zip file here and just kick it off with a customer demo, and this one as a customer reference. It's just so that it shows up in my filter, which I have currently active. There you go. While this is doing its thing in the background, there it is, auto inputting. While this is doing its thing in the background, let's go back to our overview. Different solder mask colors. Yes, interesting case. There's basically a number of possible circumstances for this. There's just the case where people want to have a fancy board with different solder mask colors, top and bottom, equally different legends colors, top and bottom maybe. But there is also a number of industries which have a real need for having different solder mask colors on one side from the other. And a typical example is the lighting industry, everything that has to do with LEDs or high power LEDs or the boards that go with it. If you have customers in that area, you may have had a request before to be able to treat this, to be able to produce boards that feature different colors, top and bottom. If we say different colors, top and bottom, this has of course a first implication. As you may have seen briefly during the first seconds where I submitted this job, You will notice that via our cockpit submit, where we used to have a single solder mask color and a single legend color, this has now been split up in one for top and one for bottom for the solder mask, and equally two colors for the legend on top and on bottom. Now this is, from this version onwards, this is always going to be there, but in order not to annoy you with having to input all these fields, what we have tried to do is, as a sort of convenience, if you would go to the first color and you say it's going to be dark green, you will see that if the second field is empty, it will be automatically filled with the same color. So basically, you're in the same situation as before. The system has taken the second color for you and defaulted it to the one which is at the top. Same thing for your legend color. If you wanted to go that with a, what shall we say, a white one, your bottom one will become white automatically. Let's reopen this again and have an empty one. If you're used to the tab keys and you're tabbing away or your way through this menu, it works pretty much the same way. I have now gone from PCB thickness, where I put in 1.6, and if I am on the solder mask top, I do D for instance, dark green. I press 2 tabs and I do W for white. And there we go. So same situation without any hassle. If you don't need the extra color, just use this as a quick way to basically use the same method or the same way for submitting jobs or defining the colors as you were doing before. This is one part. So the interactive submit with the cockpit, where you will see a difference. Another way of submitting data is, of course, our email submit. And there too, if you allow me to go to preferences shortly, what you will see there is that in the list of email codes that we have available in the standard range, you will now, if you open this list, you will now find the previous one for compatibility reasons, the solder mask color as it used to be. But here you find separate items also for top and bottom. The same for legend, the previous one. If you choose to continue just with one legend color, you continue to use this one in your email subject, and then the other two in case you want to differentiate between top and bottom. That was cockpit, email submit. Third one is if you're using hot folder or web folders, you may know of the, the defaults file. In the defaults file, you will find in your setup system defaults, it's this one. This is basically an XGD file where you can also put in some standard values. Now, what you will see is that with this release, there is a new .example version of this file. And there you can pick up the things that you may want to add to your own private defaults.xgd file. Yeah? So this used to be the previous state. So this is probably, if you use it, this is probably what you will have in use on your system. If you want to take advantage of the new system with different colors, top and bottom, what you should do is you should replace these ones with these two lines, with the 4 lines that you see here, in order to get the system going. So cockpit submit, email submit, and then the hot folder and the web submit. In the meantime, I think our job has completed. What are the obvious things that you will notice? Well, first of all, you have here in your cockpit your top and bottom view, where on the top, indeed, you will have your green and white, as we had specified. No, we didn't specify. I'll show you where it comes from. And then the bottom one, where you have red and blue. The next part, where you would see this reflected, is, of course, here in your QED PDF, where you will have the same images, top and bottom, with the different colors. And then further on, I think if we scroll further down, after the stack up, yes, there is this files section where you will also be informed about the different items for top and bottom, if they the different colors for top and bottom, sorry, if you have chosen them to be different. Yeah. Now, where does this information, this job that I have submitted without adding any parameters, where does this information come from? Basically, the archive that I submitted has this Gerber job. And for those of you who are not familiar yet with the Gerber job is a sort of JSON format, which is a UCAM format that is described and published. You can find file descriptions on our website as well, under the Gerber chapters. Sorry. And in this particular case, what I have done is I have actually made the colors for top and bottom, legend and solder mask. I have made them part of this Gerber job file. As said, this is a JSON file, which has a number of possibilities. I think if all goes well, I may have the document that explains about the Gerber job file open in here. As I said, there is this format is published on the website. There are examples. A number of CAD systems, I'm happy to say, are generating this file format. And it is, of course, very convenient because it helps you not only to convey colors for legend and solder masks, it also has the ability to contain a whole lot of other information. I just want to bring it up for your attention. This is what we call the Gerber Job Editor. This is the graphical user interface. Basically, it's a freeware program available also on the UCAMCO website. And in here you can see, for instance, the items that you can specify in this Gerber job, amongst which the thing that I have just used is in the section material stack up, the item where you can say, okay, my legend top is going to be white, the solder mask top is going to be green, and so on and so forth. The mask bottom was red and the legend bottom was blue. Now, if this information, if a Gerber job is part of a zip, our integrator software will recognize this, query it, and whatever information it can pick up from there, things like board thickness, or in this case, these colors, that will all come from the Gerber job. So this is basically the thing that you saw happening just a minute ago. Finally, and because this link with the Gerber job, you may notice that the colors in your color lists in Integr8tor have changed a little bit, slightly, and that is basically to streamline them with the colors that you just saw in this little editor. So we've geared them one to the other so that they make a perfect integration from one to B. Okay. Good. Next one is basically falls more or less in the same category, the surface finishes. A number of our customers had flagged the absence of what they call flash gold as a surface finish. Flash gold is a more cost-effective nickel gold surface treatment than the traditional one, and as any surface finish or surface finishes in general are usually an important cost driver, and nickel gold or flash gold, sorry, is no exception to that. So because it can make a difference in the quotation that you make, it only makes sense that you have that information available also from your Integr8tor software. And so we have added the flash gold surface finish as part of the list of finishes that we already had. If we go back to cockpit very briefly, and we would do a submit job, there's our list of the surface finishes. You will find the flash gold over here, and you will also see, basically in the same line as what we said for the colors for legend and solder mask, you will also see a more extended list, or an extended list, a more exhaustive list, I should say, with surface finishes. And that is because we have also here, we have integrated a few of the surface finishes that were available in the Gerber Job file, to make them available here as well. So in the same context, to be or to have a perfect integration between data that may come from a Gerber Job and that goes into the into your integrator system. Surface finishes, the new ones, just like these colors, are free of charge. There is no extra licensing involved. If you have, and I think most of you do, if you have the auto analysis license, that will do, and under the upgrade to this current version of your integrator software, you will find these items becoming available. The third one in the list of QED extensions is the VIA in path recognition and reporting. Again, VIA in path is quite an important cost driver in PCB manufacturing, and therefore it is crucial that we try to be as accurate as possible on detecting and reporting the VIA in path situations in the incoming data. Now, in all honesty, the previous versions were sometimes misled, and typically, for instance, cases where there's the big heatsink pads were sometimes picked up unwantedly as VIA in pad. So what we have done with this version is we have made this engine that recognizes the VIA in pad situations, we have made it more robust. And that has helped us to rule out the false calls that we were seeing before. Again, because VIA in pad is an important item, if there is a true case, a true situation of VIA in pads, it might lead to plugging of holes and that sort of thing. So it's important that this recognition is correct. Recognition is one thing. For the reporting, we have fine-tuned our single line previous reporting that we had in the summary table of the QED report. We have now broken this up into two items. There is a VIA in pad that talks about PTH, so through holes, and there is a VIA in pad which relates to blind drill holes. Now, the PTH one, because you usually have one PTH for your board, the VIA in pad PTH one is a simple yes or no. For the case of VIA in pad for blind drill layers, there of course there can be more than one blind program. And for that particular item then, we have chosen to report them in the way that you see here. So a span from the how would I say, the blind drill program that is concerned. So in the example here, there would be a 1-2 blind drill and a 1-3 blind drill, and in both these drill files there would be situations with VIA in pad, which can then be further seen via checkbit. I think if we go back here, there is a VIA in pad here, for instance. And if we have a look at the QED report for that, the PTH here in this case is exempt, is nothing to do with any VIA in pad. However, in the blind, there is situations in the blind from 1 to 2, from 1 to 4, and the 5 to 6, so the bottom one. If we look at the stack up, this is actually the product. It's a 6-layer board where you have one through hole, where we said there is nothing to be found in terms of VIA in pad. And then in these 3 other drill files, those would be the ones where you are interested. And then depending on your stack up or the way you're going to process these layers, you can then derive what needs to be done in your in the manufacturing process, and hence also have a correct quotation if you want to take that information into account beforehand. Right. That was our VIA in pad. The next one on our list is the copper thickness. The copper thickness for copper layers, that is. Here too, just like with 2 items earlier in this first section, we are gearing, or we are making a better connection to our Gerber Job file, and in this case also with our UCAM-XWE application. UCAM-XWE is the small UCAM-X application which is linked to your integrator, where you can do edits or things that where you can add information that the system integrator was not able to find or to detect automatically. Now, why is that important, copper thickness? Basically because when you say you have a clearance of, say, 120 micron, the clearance, the value 120 micron is of course important, but it's only half of the story. A 120 micron may be okay to make in a 70 micron copper, but it may be less evident to make or to create that same clearance or track width for that matter. It doesn't make a difference. It may be less evident to make this 120 micron into a copper thickness of 70 micron or even or higher values. Yeah. So therefore, if you want to have a more accurate view on your manufacturing problems that might occur on a certain job, it is very helpful if you can add also the thickness of the copper layer into your whole calculation, into the equation. And that is what we are doing in this version. We are again picking this copper thickness up from the Gerber Job file if it's available. If you just allow me to go back very quickly, this was our stack up that we used before. If you would click on copper layers, you would see that there is possibilities here to define the thickness of every copper layer individually, as well as the intermediate dielectrics that go between them. Yeah. Now, the dielectric thickness is less relevant. As we said, what is important for your QED is to know whether your clearance or your track width that has been found, whether you're going to be able to do this. This screenshot shows basically what you would have after reading in data that, again, has had a Gerber job. I think we can even use the same one as we were looking at before. So this was the job that I submitted in the beginning. And if we go to just the stack up, for instance, you will see that indeed the copper thicknesses have been taken over and are now sitting inside this data set. And that in turn allows us to, as you can see over here, that in turn will allow us to, if we go for instance to the part which says here the file list again, it will be displayed here. So that means that also in your QED XML file you will find the information about the copper thickness that has been coming in. And a little bit further down, this sort of information then allows you, for instance, to do conditional formatting based on this copper thickness. So the example that we made before, 120 micron may be okay in 70 micron copper, but maybe more difficult in a thicker layer of copper. So taking that information into account, what you will see in your QED is very easy and at the blink of an eye see where there are any manufacturing difficulties to be expected, either because the value is simply too small or because the value in relation to the copper thickness is not working out the way you would want. If the copper widths have been delivered like this, you should see them in your UCAM-XWE. That was the other item that was related to these copper widths. So when they have been input, you would take a layer or a job, as you see in here in your job editor. If you go to your layer modify, you will see that these values, they are being repeated here. But also saying that if you just have a job without any Gerber job extra information that defines the copper thickness, from now on, your UCAM-XWE is also able to take your manually defined copper thicknesses from here, and then after saving the job back to the Integr8tor server, that will produce the desired result in the same way as we just saw on the screenshot and on the presentation here. Okay. This too is without any additional license, so you have this to your availability with basically just the licenses that you have. Good. I think that concludes it for the extensions. Bringing us to the second part, where we said that we wanted to expand a little bit on the Gerber X2 input in this Integr8tor version. As you probably know, the Gerber, and more specifically the Gerber X2 format, has the ability to convey component information. A CAD system that has all its component libraries, and when it's done designing a board, when it outputs the manufacturing files that typically go to the fabricator, a Gerber X2 dataset can actually contain 2 extra layers, which by their attributes will be recognized as component layers. In theory, that means that what you see here, for instance, is a snapshot of a header. And somewhere in this header, there will be a file function attribute. And if this file function attribute says component with a designation for top or bottom, then what will happen is Integr8tor will see this, read this, understand this, and it will make it will turn this Gerber layer into something a little bit special. That is, there's basically 2 ways. Of course, a component layer is just a Gerber layer. It has a number of lines and a number of flashes and things that you would imagine to be a component or a component outline. So as such, you can always read in a Gerber component layer and just look at the component information. I think if we go back to our cockpit here, and you would take the normal route, this would be a data set, I think, from KiCad. Is one of the CAD systems, a popular one, that generates component layers in an X2 Gerber X2 data set. And if you would, for instance, have a look at this first layer here, which has the function component, this is what you would get. So it's basically, well, you could compare it a little bit to a legend, but it has a number of other items in there, and then the typical legend designators, or whatever, the G10s, which are not there. But it's basically, it looks a little bit like a legend layer. If I were to take this into my UCAM-X, let's get out this one maybe, and we go to here. Then what you would see in the normal situation, in the standard situation, without any whistles and bells, is basically in your job stack up, you would actually have this as a component top and the other one as component bottom. So pretty much the same as what you were seeing on the screenshot earlier on, or on the PDF. Yeah. Now, what is different and a new possibility in our latest release of Integr8tor is that you can read this same information, so the same component layer, that you can actually read it in after you have plugged in an extra license. And this extra license will take the Gerber X2 component layer and sort of translate this into what we would call a UCAM assembly layer. And although at first sight this looks the same, okay, it's a different data set, but the principle is the same. You have a layer which is of the type component, top and bottom. if now, after reading this in with the dedicated new license for component Gerber input, you will see that the aperture list, for instance, of this component layer is completely differently structured compared to what we were seeing before, in the sense that everything that represents a component now has been grouped together into blocks. It gets names. There is all sorts of attributes sitting on these blocks and on the items inside the block, which basically allows you, well, first of all, just to do your own scripting, if that is something that you would be of interest. If you are in the EMS or you're looking into the area of assembly, then you might want to extract from this some bill of materials or whatever to get going. What this extra license also does is, if you go to this menu here, it's also available from View Query Component. That's the official name. I've accessed here via the workspaces. But this added license that has upgraded the incoming Gerber X2 component information into this assembly data, this now allows me to use this query component function, which is going to allow me to review part names, reference designators. I can show pins, I can show the copper and how it's linked to this. I can see first pin, I can scroll through them and see how this all comes together. So it is actually a sort of much bigger potential that you capture by using this new extra input license that we have for Gerber X2 component information. So to cut a long story short, the component layer in Gerber X2 is just a Gerber file, and it will read in just like it has done before. However, if you have interest and have installed this new license, extra license, then this will make sure that your Gerber component information turns into what we see here, a sort of added value data set that can be used towards assembly or EMS. Yeah. That means that, of course, the basic part, just reading it in, is free of charge, no extras involved. If you want to upgrade your input to feature the more advanced capabilities, then there is a cost option that comes with the license. Okay, so far for the Gerber X2 input. Let's move on to the next one, and it's actually a collection of, I think, 7 or 8 different items, which I want to go over with you very quickly. It's all about speed improvements in the past, or since the last version that we made. We've actually worked on quite a number of modules inside Integr8tor to make them more performant. And what you see here is basically a listing of all these modules that have been reviewed. Starting with the via plug and plated to copper analysis, the clearance analysis. These two modules have been found to be quite taking up some of the processing time in Integr8tor. Especially when for jobs with more complex plating structure, like in the case here that you see, there is quite a lot of blinds and buried, and the via plug is basically a sort of module which is going to find out if there are any drill holes from one layer that are stacked onto drill holes from another layer. So you can imagine if you have a whole lot of these files to start with, And within these files, you're then looking at maybe a couple of thousands or even a couple of tens of thousands individual drill holes that has been identified as an area where, as I said, processing could take quite a lot of time. And it's one of these areas where we have redesigned these modules in order to make them faster. In our dedicated test queue for this, we've seen cases where 80% in speed or an 80% speed up could be witnessed. That means that if a job used to take 100 minutes, it would now do the same thing, but in 20 minutes. Yeah. So just to give you an idea. Now, although this is basically a general improvement, you're going to be noticing this best on, as we said, this type of jobs with many drill files, and in these drill files, quite a number of drill holes. So if you think of any layer technology or substrate like PCBs or test boards, then this is, if this is part of your portfolio, if this is the type of product that you get to do regularly, then this is certainly something that you will witness or that you will see in your processing time. So the fact that they are, or that they have become substantially shorter. In the same category, tool classification and functional copper detection is the same story basically. Tool classification is the module that is going to find out this is a via drill hole, this other one is component drill hole, that sort of thing. Functional copper is something that we use in order to make accurate reports, in the sense that you don't want to get copper widths reported on something which is text and that sort of thing. So in order to do this, we need to be able to say what are the functions, the different functions of the drill tools, A, and B, what in this copper image, what is functional and non-functional, and the two are sort of closely related together at some stage. Now that too was something that we noticed on specific jobs that could take up quite some time. So here too, these modules have been redesigned, and the section below here is courtesy a customer. There is an overview of, I think, 9 or 10 jobs in here. You will see the number of copper layers. So again, it's not your average run-of-the-mill 4-layer board or 6-layer board with one plated and one non-plated drill file where you will get most benefit of it. But as you can see here, those are quite substantial products with 14 to 30 layers, back drilled with a number of back drills, and a processing speed as the customer reported it at that time before the speed upgrade, and then on the same system with a software version where we had incorporated this optimization. And in the last column, you will see the relation between the two expressed as a percentage. So if you look at this last column, it is, in many cases, it is quite impressive. There is the one that stands out on the negative side almost, I would say, is this one, because it is only 6% speed gain. But if you look further down this list where you get into these more complex products, you're looking at a original processing time which was 4.5 hours almost, which goes to under 1 hour. So this is actually, again, quite substantial. Again, if this is the type of work that you get to do, then there too you will be, I hope, I know for sure, you will be pleasantly surprised to see these jobs now coming through in much shorter times. For those of you who deal with flex rigids boards or flex boards, and who have to deal with cross-hatched layers, cross-hatching is another one in this category. It's it's not about clearance, but the calculation of the line width on layers that have cross-hatching is or can be a time-consuming process. And in this version of our Integr8tor release, we have implemented or incorporated a completely new algorithm to deal with cross-hatching. So there too, on yet another set of test cases, we have seen speed increases of up to 70% on jobs that used to take hours before, where they now will run in 20 minutes, half an hour, something like this. Having said this, this is still work in progress, in the sense that we do good job, reliable results, quick and everything, but we may still not pick up a job or a layer that is affected by cross-hatching. And if that were to be the case, if you happen to pick up on one of those, you're very welcome, of course, to forward them to our support department so that we can further fine-tune this in the next releases of Integr8tor. The speed up item that we're talking about here is something that you may recognize. You read in your data and you don't get the single image, but you get some repeat onto an assembly panel, or in the worst of cases on a production panel. That too had a tendency to slow down Integr8tor or to create longer processing times. And here what we have come up with is an algorithm that will recognize repeated patterns in the copper. And once these patterns have been recognized as being, okay, you're the same as the other one, this has helped us again in speeding up the, in this case it was the copper and trace width calculation times. That helps speed up that part of the work. So in total, again, jobs, this type of jobs with this type of construction of data, you will see them going through your Integr8tor in a much shorter time. I think the screenshot here is from my system. One was taken back in September last year when we were still working on this. It was 3 hours plus, and today this will run in under half an hour. So that too is quite amazing. So if this is a type of item that sometimes hits you, you will be again pleasantly surprised to see that performance has massively increased on this type of work. And the same can actually be said of the following one. The following one is the layers that have copper thieving already on the incoming data. Copper thieving is normally something that the fabricator puts in, but in some cases it's part of the incoming Gerber data. And that too was not always a big joy to treat, let's say. Jobs that had this sort of patterns, they could actually be running for quite some time. So we've now added new logic for the recognition of thieving patterns, and the analysis is dealt with in a special way so that this sort of layout too is now going through much faster than before. Maybe you recognize this one, small clearances in copper plates that are basically smaller than the hit. So blue is a drill hole, red is the copper, and as you can see in these cases here, there is the drill hole basically going through the copper, but somehow in the design or in the design system, there is a small, very small clearance left underneath this plated hole. That too has been found to be a performance issue in some cases, slowing down the system unnecessarily. And there too we have made adjustments so that these data sets are treated much more efficiently, and again that their processing times only represent now a fraction of what they used to be. And I think the last one in the speed optimizations is what we call the submicron aperture handling. Now, typically on legend layers, and don't ask me why, but on legend layers, CAD systems tend to put these tiny little minute apertures with aperture sizes that are less than a micron. And that too was something that the integrator analysis was not particularly happy about. So what we have done again in this release is there is a new way of dealing with these with this sort of apertures, and again, as a result, there is a much higher throughput of this sort of data sets that feature this what we could call design peculiarity, because basically there is no reason to have this in your legend, or maybe even in any of these layers. But okay, they are there, they must be dealt with, and as we said in our latest integrator release, they are dealt with in a much more efficient way than before. Then coming to the last part, oh yeah, by the way, these all these speed improvements, as I said, there were 6 or 7 or maybe 8, I don't know, they come as part of your upgrade, so there is nothing special or license-wise something that is related if you install this version and you treat one of these, this type of data sets that we've been discussing about and where we've done the speed updates, then I'm sure you will find a difference between what it was before and the processing times that you get now. Finally, some functionality improvements. One is a server-initiated log-off for cockpit connections. The situation is a bit typical. You have a cockpit and an integrator server, and imagine that at some point the connection between the two is lost in, let's say, an unfriendly manner. That could be a network disruption or a power outage affecting one of the two. Now, under normal circumstances, if the company is under the same roof, this is usually okay to deal with. But imagine the case that your server and your client, your cockpit, are in completely different parts of the world. One is, for example, say South America, and the other one, the server, is sitting in China. Imagine that there is a problem somewhere between the two and the two get disconnected. That could lead to situations where the server would still think that a cockpit was still running with a certain username, and that there was no possibility anymore to get, how would I say, to get the cockpit in my example in South America, to, after the incident had been restored, to log on again to the server. If somebody on the other side, IT-wise, was available, that could easily be solved. But as you're talking different parts of the globe, the time zone may be an issue, and it's not always guaranteed that there is somebody on the other side available to help out. So with this new instrument, this edition, what we do is we allow you to set up what we call a cockpit idle time on the server side. And if the server finds that he has not had any response from a cockpit user within the given time, then the server will assume that this cockpit user is no longer either there or something has happened, and he will log this user off after the time out has expired. Now, the timeout with the software version is hard-coded in as 180 minutes. If you're not interested or it's of no interest, then you simply put a value 0 to disable it. If not, you put it to any other value that you find useful. That's an extension that goes into users' preferences, which most of you will know, but in the global section, so not the the job profiler node, but in the in this one, in the global. Yeah, as you can see here in the example. Stack-up recognition improvements, that's an evergreen. In every release we do something about stack-up recognition, and that's because we highly value a correct stack-up recognition, because basically that is a prerequisite for getting high first pass hit rates. If you have your stack up right the first time, it means that your QED results are complete and correct. And it also means that you don't have to redo part of the analysis after a manual intervention, setting something right. So the higher the hit rate that we can get in stack up recognition, the better the throughput, because as we said, you get from start to finish in one go, and that's the end of it. So that is something that we always do in all of our releases, and this release is no exception. You will find your new Integr8tor version with functionally extended engines that will better pick up drawing layers, or that will filter out drill spans that are hidden in ASCII texts that are part of the archive. It will do a better job recognizing back drill layers and so on and so forth. So an ongoing effort all the time, and we hope that you can and will appreciate this as well. Another one of these functional improvements is the handling of empty layers. Now, I can already hear you say nothing can be simpler than handling an empty layer. That is only partly true, in the sense that there are some CAD systems that will generate always the same stack of layers, let's say, always the same paste top, legend top, even though for one particular board there may not be a need for a paste layer at the top, for instance, or a paste layer at the bottom, whatever. Still, they always put in the same numbers, and if the layer doesn't contain any data, okay, so then it's an empty layer. Now that usually works and works well. And historically, Integr8tor has always had the approach that if an empty layer comes in, we take it out of the stack and we just give it the function empty, as you can see here in the screenshot, and put it down below, which is good and works well. But there may be some sort of a special case for solder masks, in the sense that typically the data that you get in the solder mask is the area that is clear of solder mask. So if you would now get an empty solder mask layer, maybe it has been intended to say that this side of the board should be completely covered. And at that point, taking the solder mask away and putting it empty is basically just going to go to, after a review from the operator, he will probably have to set this back interactively, manually, as an empty solder mask layer for top or for bottom, whatever, and then redo a part of the Integr8tor processing. So in order to avoid this, this version comes with a system wherein, again, user preferences, in the job profiler workflow this time, you can actually add a comma-separated list of layer functions with which you say that even though a layer is empty, if it's of the type mask, paste, or silk, for instance, in my case, it should remain in the stack up, even though it is empty. Again, this has one big advantage. If you can set this up by default and beforehand, it will save you a number of partial reprocesses, because the solder mask, for instance, would have been qualified as an empty layer and taken away from the stack. So that too might increase your first pass hit rates to a certain extent. Then finally, we come to an item tray scripting. Tray scripting is an automation method that exists in Integr8tor. And in trays, or with tray scripting, you have the following situation. You might want to write a script yourself and you attach it to the tray, but the tray in itself also has a function which has been dictated by Integr8tor, standard functionality, standard software. So a tray may, for instance, have the function, I'm going to do a clean job output, or I'm going to do an ODB output. Okay, and now to that same tray, suppose that you want to add a script to this. Then the question is, okay, who comes first? Do we first do the script and then the ODB output in my example, or is it first the output and then the script? There is no right or wrong in this story. There are cases where you definitely want your own script to run beforehand. There are other cases and scenarios where you want your script to wait until the other action has completed, and only then your script should come into action. Now, there is a very convenient way to deal with this from this version onwards, and that is that if you have your own scripts and you attach it to a tray, any custom script will be executed as the first. Yeah, so first your own script and then anything else this tray would be doing, unless you are going to name your script in a specific way, and that is by prefixing it with a post underscore. If that is the case, the system will know that it will first have to do the standard tray operation, and only once that has been completed, it can then continue with your custom script. All of these items here too are free of charge. They come with the version upgrade, so I'm sure, or I hope, that you will find some of them that will be, or that will prove helpful to you in any of your situations. That brings us to the end. There is, of course, also the list with fixes. We're not going to go through them, but from the document you will find them in here. That too is part of our regular development of our Integr8tor software. So there too, I hope you will find a number of things that you find more convenient or happy to see that they are resolved. Okay. Right, then I think we have covered most of what I wanted to show. Thank you for watching this video. Stay tuned, we will be back with more. Have a nice one. Bye-bye.